Yesterday we talked about basic data types, as usual that we have in other programming languages. And also we came to know about what is functional programming language. Functional programming language is all about avoiding mutability. Sorry, I mean to say avoiding mutability is a very generic statement. We can avoid mutability in many ways. We know that Scala has made its collections as immutable. And also if you try to return something from a function, that function is nothing but a immutability function. So the idea here is to have a clear-cut differentiation between mutability and immutability. Any function that does not return anything, it's a developer responsibility that that data has to be saved somewhere. If you don't return, we have to save somewhere. In that case, it becomes a mutability function. Otherwise, it becomes a immutability function. So keeping that in mind, we also saw that there is a jargon called expression. Expression means a unit of code. Expression means unit of code that returns a value. So again, it means that it is a immutability thing. It's all any jargons you come across here. Mostly they are they will boil down to mutability and immutability. So yesterday we also saw a block of expression. Yesterday we also saw a block of expression. We can write a block of expression using the parenthesis. Sorry, not parenthesis, open flower bracket and close flower bracket. We can have this. We just saw one difference there when we said val y is equal to 20, and if we have the last statement without any assignment, if there is no assignment, that expression gets evaluated and it will be returned from this block of expression and it will be assigned to whatever is on the left hand side of the equal to sign. And the data type is also automatically inferred. This we saw at the last. Similarly, if I say val x is equal to 10, and if I say val y is equal to 20, and if I say val z is equal to x plus y, this will not return anything. If it this that's what I was saying. An expression is a unit of code that returns some value. Everywhere you will see something or the other thing being returned. There will be everything. You will see that there will be something being returned. Here nothing is being returned, hence it is called unit. The return value, they represent it as a parenthesis. Here the return data type is a unit. So I hope things till here things were clear. Yeah. One more thing, we can write a block of expression on a single line also. We can write the same block of expression on a single line. Val y is equal to 20, then I will say z equal to x plus y. It's the same thing. But what we have to do is, this is where the semicolon becomes mandatory. Otherwise, I said that semicolon is not mandatory. Otherwise, it becomes a mandatory, because we have to differentiate different expression, multiple expression. Otherwise, the compiler cannot know that this is the end of the expression. Compiler will not know that this is the end of the expression. So to differentiate different expression on a single line, we use the semicolon. If I don't give the semicolon, obviously I will get an error because it was not able to differentiate the end of the expression. So I have to specify a semicolon here. I have to specify a semicolon here. What did I do? I did not specify val here. Val z is equal to this. So you have to specify the. So here is a question. The question is, what is the difference between expression and a statement? We will see that. The next thing itself is our same thing. So all these things we saw. All these things we saw. So if we see, next we have the statement. Statement is also an expression. It is just an expression that does not return a value. That's all. These are all just jargons. We don't even, we can give any name to those jargons. The only thing we have to understand is what is the meaning of that jargon. What is the use case of that jargon? The meaning is nothing but boils down to again mutability and immutability. So if you see here, a statement is just an expression that does not return a value. So if I say here, let's say we have a println hello Scala. So it just prints the content here. So this is a function. We know that println is a function that takes string as a parameter or anything as a parameter and it will print it. Now what is the return? What does println return? What does println return? Any idea what does println return? Any guess? Any guess on what will it return? So we can check that. We can always check that. I can say I can capture that return value in something val x equal to println and do the same thing. So we can see this. What is the x data type? Whatever the println function returns, that return values data type will be x data type. So we can clearly say that x is of the type unit. Meaning println function does not return anything. This function does not return anything. So such kind of a functions or expression we call it as a statement. So what does that mean? The meaning is same thing, mutability and immutability. Unit of code returns a value, meaning it is immutable. Statement, no return value, hence it is a mutable. So obviously println should be doing some mutability here. Obviously println should be doing some mutability, some modification. What it is modifying? It is modifying the console. It is writing to the console. So that's the mutability we are achieving. That's the mutability we are achieving. So that's the difference between uh, expression and a statement. So this we can call it as a statement. So I hope, Kishore, that was clear. Okay. So the jargons are just for language purpose. It is all about the meaning of that jargons. So finally, it boils down to mutability and immutability. So we'll see what is a if-else expression here. If-else we know in all the programming language. In every programming language, how do we use a if-else expression? We do something here, right? We say if some condition here, else else if we have some condition here, else we have a condition, else something here. So in most of the other programming languages, we modify something here. We modify something here. That's how we have learned if else condition. We always try to modify here. The same thing holds good for Scala as well. Along with that, it can return some value. Scala can return some value. So that's so it can be used as a mutability expression. It can be used as an immutability expression also because it has the ability to return some value. In most of the programming languages, we only modify probably some global variable we modify, or an array element or a collection element we modify. Something we keep on modifying. That's the best use case we have seen. The same thing is also available in Scala. Along with that, we can also return some value. We can also return some value. So that's the reason we call it as a if-else expression. If-else expression. Expression, we know that meaning, it always tries to, it is a unit of code that returns some value. So when we return some value, so we can have an equal to sign before that. If here is a question, if no return value is mutability, what happens if the object is of the type val? I mean, wherever you want to write it, that's the developer's responsibility. I mean, we cannot write it to a val object. We have to make sure that we have to write to a variable object or a file or a database, such kind of a thing. Otherwise, it will give an error. Obviously, it will give an error. So I hope that's clear. Actually, it's our responsibility to take care of that. Yeah, keeping that in mind. As I said, since if else is an expression, if else can also return value. So when it returns some value, so we can have an equal to sign before this, because if also returns a value. Hence we will usually see a equal to sign also, which in most other programming languages we don't see. Here we have a follow-up question. We shouldn't write in val type variable. Yes, we usually don't write in a val. We usually don't write a val. The question is, we don't write in a val. The meaning of that is a bit different. So let's say we have a class of, say, val x, val y. We usually don't modify this class x when I say, uh, sorry, class ABC I will say. So I can say val ABC is equal to new ABC. So if I try to modify, I should create one more object of this class. I should not modify when it is val, I cannot modify, but I can always create one more object with the modified value. Val xyz I can say. So that's the idea. You always create a new object with that. That's the idea. Even though it is val, we can modify. That modify means the original data remains as it is, a new object gets created from the primitive data types to the user-defined data types as well. So I hope that
Uh,
was.
Sorry for this. That's it. About Rashid.
Yeah, yeah. Go ahead, Rajshekar.
Yeah, it said, right, the val and where. Difference is that val is immutability, right?
Yeah.
Uh, if the val is immutability, whether the reference type is immutability or object itself is
No. So wherever we have a val, all those things becomes immutable.
immutability.
Wherever we have val, inside the
Cannot modify
members.
the object or we can,
No, no. The if the object we can define as val. Everywhere we have to either specify val or val.
yeah, yeah, exactly. Suppose if I define the object ABC val, I'm assigning that val to where I can modify the object, right?
Uh, Come again.
See, first statement is I am going to define a val ABC equal to new ABC object. Okay?
1 second. Let me say class. Let's say x, y, z, and you have some val x, val y. Yeah, this is what you are saying, right?
Yeah. Here, val is immutability means XYZ is immutable. It means that we cannot assign anything to the XYZ, right?
Correct. You cannot assign anything to x, y, z.
Okay. If
Yeah.
below val, if I write to where ABC equal to XYZ, so I can show that where you can modify the XYZ object.
If I say where ABC is equal to
Equal to XYZ.
new x, y,
XYZ,
z.
not new, not new, not new. Only XYZ.
Sorry, I lost your voice.
Sorry, a reference variable.
No, no, we are.
Uh,
Yeah, this where ABC is there. Now, what's the question?
ABC equal to XYZ. Variable, val variable.
Yes, yes, we can assign that.
So that ABC we can modify the object.
No, internal object you cannot modify.
So even though it assigned to where, right? See, here can you write the statement
So
where ABC equal to XYZ?
this is modifiable. We are saying this is modifiable.
Yeah, yeah. My question is ABC equal to XYZ.
Right.
No, no. Can you remove that new XYZ? Can you remove that?
Okay.
Assign XYZ.
Okay.
So here, I can modify the XZY object, right? XYZ object I can modify through ABC, right?
But actual XYZ will remain as it is. We are just
Yeah, but
assigning that object to ABC. That's all.
yeah, that's correct. This ABC referring to the XYZ, right?
Yes.
Both memory is same.
Both memory. No, no. This will be allocated in some memory.
Hmm.
This will be allocated to some memory.
Yeah, but same object, they're referring to same object memory, right? Same object memory.
So if you see,
But
this is the object. Somewhere it
yeah,
is allocated.
yes.
Now XYZ will point to this.
Hmm.
Similarly, one more object got allocated in the memory. Now ABC is pointing to that object. Now we are
Oh,
making
is it?
this object to point here.
Yes.
That's all.
Yeah.
But you
Now,
cannot make
both
anything, any other objects. XYZ cannot point to any other objects now.
yeah, that understood. That understood. My question is, yeah, ABC is pointing to above object, right? Both XYZ and ABC both are pointing to the same object.
Correct.
So through ABC, I can modify the object, right? Because ABC is a where of type modifiable. Okay.
I
So
mean,
through ABC, I can,
correct. What does that mean? Where means modifiable means this object was assigned to ABC. Now this object is assigned to ABC. Now if I create one more object also, I can assign to ABC. So if you see, different objects are being assigned to ABC because it is where.
yeah, but I can modify the object.
Now that itself is called modifying the object. You are assigning different
Okay.
objects to ABC. That itself is meaning as a where. So you are trying to say internal of the things, modifying the objects. Are you meaning? Can I
My
say
question is not modifying the reference. My question is modifying the object.
okay? Modifying the object meaning. I didn't get that.
Say for example, XYZ object value XY is X is 10, Y is 20. Okay.
Right. X is equal to 20. Y is equal to 20.
Yeah, fine. So here is the XYZ is 40. Some value XYZ is 40. Okay, something. Okay.
So X is 10 comma 20 is here. Yeah.
Yeah.
Here 40 comma 50 is here. Here 80 comma
No,
90 is here.
yeah. My question is ABC is pointing to object 10 and 20 right now, right?
Right.
So through ABC, I want to modify instead of 10, I want to modify 30.
You can modify making it as var. You cannot
Yeah,
modify.
that's
So this again internal variable has to be identifiers has to be val or var. So if it is a val, you cannot modify.
so where is I can modify the object. So where?
Right. We can make x as var here.
Yeah, where ABC. Yeah, I can modify the ABC object. ABC object is having the pointing to object 10 and 20. Now instead of X 10 and 20, I can modify by 100 and 200. I can
Yes.
modify that
Yes.
object.
If it are both are var, I can make it as I can make this as 100 and 200.
But XYZ is not modifiable. But I
No.
can modify the object.
Yes. Yes. XYZ modifiable because it is val. Meaning of
Mhm.
that is you cannot assign any other objects to this. That's
I
the idea.
understood. But I can modify the object, not a reference,
Correct.
right? I can
Correct.
modify the object.
Modify the objects meaning again internal if the members are var only then you can modify. Otherwise you
Yes,
cannot
exactly.
modify. That's fine, right? Yeah. Keeping this in mind, let's move ahead with the as I was saying, we can have a equal to sign before the if expression. Equal to sign before a if expression. So when I say such a thing, so I can say val x equal to, I can say if condition, I can say if 10 percentage 2 is equal to 0, then I will say divisible by 2. Divisible by 2. So the compiler takes care into account the return value from the if condition as well as the return value from the else condition. Even though you don't write the else condition also, it will take care. it has to decide what will be the return value from the if expression and what is the return value from the else expression. So keeping that in mind, so we know that the body is returned as I said here. As I said here, the body is returned. Whenever I say if as an expression, it will evaluate the body, and it will return from here. We don't have to use the return keyword. Whatever we know that whatever is the last expression in the block of expression, that will be returned after evaluating. So that's the idea here. Here also we don't need a open flower bracket, close flower bracket if there is only one expression, as usual in other programming language as well. Here is the question: is this possible only in functional language? Which one, Kishore? Right, right. Usually it is done. I mean to say, it is because of the functional language. Because of the functional language, we are trying to return some value and assign it. Otherwise, we usually don't do that. So now the question here is, we know that the body will be evaluated and returned. So now what will be the data type of X? The question here is, what is the data type of X? Any?
Data type of the last expression of the block.
Sorry.
Data type of the last expression of the block.
Yeah, it looks to be the data type. The last expression is nothing but the string here,
Yeah.
because we are only having one expression. So it looks to be a string, and let's see whether it is a string or a. So if you see here, it's totally different. It looks to be a string at the first, when we see it the first time, but it gives a altogether a totally different data type. We have never seen such a data type in Scala or any other programming language. So what is this data type here? So if you see here, any is the superclass. Any is always the superclass. So it returned the data type of X as any. But where was our return type? We were returning string, but it set the data type as any. Why it was done in such a way? The reason it was done is because let's decode that code actually. So we had, if 10 percentage 2 is equal to 0, we said divisible by 2. We just said this, and we said val x equal to. We are returning some value from the if expression. So as I said earlier, the compiler also takes care what will be the if return value and what will be the else return value, even if we don't write the else condition. So if I decode that, if this condition is true, if the condition is true, we are returning string. Let's assume what will be the else. If the condition is false, what is the return type here? If the condition is false, what will be the return type? If the condition is false means there is no code to execute. We don't have any code to execute. So since there is no code to execute, nothing will be returned here from the else expression. Since nothing is returned, the return data type will be unit in that case. But we are trying to return two different data types, and we are trying to assign that two different data types to a single identifier, which is not a which doesn't happen. You cannot assign two different data types to an identifier. It has to have only one data type. So that data type is taken as the common parent data type. So if I see here, if I come here again, my string is here, which is borrowed from Java. My unit is here. So unit parent is any value, its parent is any. Similarly, string parent is any reference, so its parent is any value. So if you see, any is the common parent. It is the common parent. That's the reason the data type of that is any. The data type of that is any. Even though the value is a string value, even though if you see the value is string, the data type is any. So if I say something like this, if 10% is 2 is equal to 0, then I return 0, else I will return something as false. True and 0 and false I am returning. Again I am returning two different data types. Let's see where are those two different data types. So we can see that I am returning 0 means it is an integer. I am returning a true means it is a boolean. I am returning two different data types. The common parent is nothing but any value. The common parent is any value. So obviously now the return data type should be any value. We can check that. So we can clearly see that the return data type is any value. So the idea here is, the point to be noted here is that we have to we have to have both if and else condition to have the same data type. I can say here, never try to return two different data types. I can say divisible by 2, else I can say not divisible by 2. So if you see, in both the cases we are returning a string, hence the data type of x is string now. Hence the data type of x is string. That's the idea. So we can have in this fashion. I can say val x is equal to 10, and I can say val y is equal to 20, and I can say val max equal to, if x greater than y, I can say return x, else return y. So I am doing in this fashion. I am trying to do in this fashion. So this we can use it as a max condition. If else condition we can use to compute the max. In both the cases we are returning an integer, hence the max data type is automatically inferred it as a integer here. So I hope till here things were clear. Till here things were clear. In a similar fashion, what happens if there is a cross common parent in the if else block? A cross common parent in the sense it will always
From cross common parent in the sense that one is any value, one two. Can you open the hierarchy?
okay.
Here is any value and here is any value, right? In the string and boolean, right? There is two different parents, right? What is that, parent? String and boolean. Boolean parent is any value, right?
Right. This is what you are talking, right? Two different.
Yes.
So it will take the common parent. I mean to say, any is the common parent.
Here is what is the string immediate parent?
Sorry,
Any value, right? String immediate parent.
immediate parent.
I mean, yeah,
Any.
any value, right?
Sorry. I think you go ahead.
Yeah, a string immediate parent is any value, right? Any value, right?
No, no. String any reference.
Oh yeah. Oh, what in that case? What is that? What happens if the my if else conditions, one is boolean and one is string? What type of that assign variable type?
No. That's what we. So the common parent is this.
Okay, okay.
So it is any is the parent of unit also, any is the parent of string also. So the common parent will be taken. Yeah.
Okay.
So as we have, if we have more than if else condition. So if you remember other programming languages, we use switch cases. We use switch case. We specify some expression here, and we have case here. Case 0, case anything. I will not specify the data type here, and we'll have a default. So why do we need a case statement? We usually require the case to get rid of multiple if else condition. So this gives a more readability than having lot of if else condition. So that's the idea of the switch case. In a similar fashion, in Scala, similar to switch case, we have a match expression. We have a match. Here we have switch keyword, other programming language. Here we have match keyword. The expression is given after the switch keyword. Here the expression is given before the match keyword. It is given before the match keyword. And then we have the case. Similar. So that's the similarity, or I can talk about the match or switch. But it is a bit more than that. Match expression is a bit more than that. Meaning here in the switch we can, the cases could be only primitive data types, like a boolean, like an integer or a double, such kind of a thing, a primitive data type. Here the cases could be, here it could be primitive and complex data type. The meaning of the complex data type means I can have a case list, I can have a case class also I can specify, not just 0, 1, such kind of a thing. I can also have these things. So that's what match expression is, more than switch statements we can say. So but we need to have certain use cases. Without having any use cases, what would be the, why do they simply have complex data type also as a part of the cases here? So we will see that as well, what will be the use case of that. But first we need to understand collections for that. First we need to understand the uh, classes also. So once we learn that, first we'll start with primitive data types. Then we'll learn collections, then we'll learn classes, and then we'll fall back to again match expression with complex data types. So but the idea is same. Instead of switch we can use the match. So to make it work here, so I can say val, we have already defined x and y. We have already defined x and y. I can have val max is equal to match, as a match is also an expression. I forgot to say that match is also an expression, meaning the match will also return something. If this case is matched, we write something, some logic will be returned here. If this case matches, a logic will be returned here. So after evaluating this logic, whatever value we get, that value will be returned from this match expression. So it will be returned from this match expression and we can assign it to something. So that's the idea of the match expression. So I can have in this fashion val max. I want to compute the same, we tried if else expression. I can use the same thing in our match expression. And as I said, the expression comes first, then the match keyword. The expression, I will say x greater than y. This is my expression. And then the match keyword. Just a bit opposite to the switch case. Then I pass that value to the match block. So what happens here is this expression gets evaluated first. After getting evaluated this expression, whatever value we get, that value will be passed to the match expression, match block or match expression, anything we can say. So what value we can pass now? What value is being passed? Either it will be a boolean, because x greater than y will always give you a boolean. So boolean means true or false. So we can have a case of true. If it is a true, I can just return x. If case false, I can return y. So here, this is a new thing, a new symbol. Scala makes use of lot of symbols. You have to initially get used to these symbols. Initially, you have to get used to these symbols. Once, I mean, the symbols may make the coding a bit tricky initially, but once you get used to that, then it is very simple. Then you will be very happy to learn Scala. So if this case matches, we are returning x. If this case does not match, And I mean to say, if this case matches, if it is a false, we are returning y. So obviously we can check this. So x is 10, y is 20, we know that. X is 10, y is 20, x greater than y will give you false. It will give you false. That false value will be passed to the match block. Hence we are checking whether it is false. Obviously it is not. This case will not hold good. Hence it will go to the next case. Hence it will go to the next case. This matches, and whatever is on the right hand side, that will be evaluated. That will be evaluated. So y is evaluated and that is returned from the match block and assigned to match. Y is nothing but 20, hence 20 is being assigned to match. And match data type is automatically inferred as an integer. It is automatically inferred as an integer. So that's how the match expression works. To give you one more example, I can say val status is equal to, let's say, 200. A simple thing. Val status equal to simple. I will pass this status to the match expression. I will say val message equal to, as I said, the expression comes first, then the match block comes. Then I say case. So status is an integer. Status is an integer. I can specify here yeah, here is a question. What is the meaning of this symbol? Yeah, with respect to match, we can assume that this is just a symbol being used to differentiate between the case and the actual logic. Like we have case colon in other programming language, here we have a arrow. So, but there are other meaning also for this arrow mark. We will see that in case of uh, function object, there are some things, function literals or lambda expressions that we call in Python. When we use that, there also we use the same symbol, but the meaning of that symbol is different. Meaning of that symbol is different. But here it is just, we can assume, we can check that it is to differentiate between the case and the actual logic. That's the symbol. So keeping that in mind, now we are having status is equal to 200, and we are passing status gets evaluated and the value is passed to the match. So when we pass the value, so we can check whether it is equal to 500. I can say if it is 500, I will return saying that critical error. Case 200, I will say success. As simple as the previous example. As simple as the previous example, status gets evaluated, 200 will be passed to the match block. This case does not match, this pattern matches. This case or pattern matches. Hence, this expression will be evaluated and it will be returned from the match block and assigned to. Now we can do one thing. Now what we'll do is we'll change the status to 300 or 404. We'll change the status to 404. So what will happen this time? I'll rewrite the code once again. Status, then the match expression, then the case. I will say same thing, 500, critical error, case 200, success. So when I have such a thing, now status gets evaluated first. Obviously it will give 404. Now 404 will be passed to the match block. This pattern does not match. This case pattern does not match. So none of the cases match here in this match block. None of the case match. So in such a case, what happens here is it will return an error. It will give a error. A runtime error you will get. So we can check this here. So we get a runtime error as a match error saying 404. So now to how do we handle such a thing? So how do we handle such a thing? So if you see in other programming languages, there is always a default case. If you see in the switch, there is always a default case. In match, there is default case is also there, but along with that, there is something else is there. Something else is also there. So how do I do that? So it is called as wildcard pattern matching. So match expression is usually called as pattern matching. So just to remember that if somebody says match is also sometimes called as pattern matching. So when you want to match lot of things, so we call it as a wildcard pattern matching. If such an error comes, so we can solve such an error by wildcard pattern matching. So there are two types of wildcard pattern matching. First is called as value binding. First is called as value binding. Second is called as default. Actually it is underscore. Default is here. Default is represented using the underscore. So let's see how to use these things in the match expression. Let's see how to use this in the match. So I will write the same code now. I will write the same code. We can use the up arrow mark to check whichever code we have already written. So status we know that is 404. So I have 500 critical error. I have 200 success. Then I will say val x or something, val anything, ABC, we can specify anything or is something. So this is what we call as value binding. This is what we call as value binding. The meaning of value binding is nothing but some assignment, that's all. So what happens here is this expression gets evaluated, which is nothing but a simple expression, and it will give you status value, which is 404 will be passed to the match block. This pattern does not match. This pattern does not match. Now what happens that 404 will be binded to X. It is just like saying X is equal to 404. Just an assignment. So, and we call it as value binding. We call it as a value binding here is because the value will be binded to S. So as soon as value binding happens, we say this pattern has matched. This pattern has matched. Since this pattern matches, whatever is on the right hand side of this symbol, which is our unknown string, it gets evaluated, and that evaluated value will be returned from the match expression, and it will be assigned to message. So that's the idea of the value binding. That's the value binding. So value binding we usually do so that we can know what is the value. We can use it further, right? We can use this further. We can have some conditions here. We can have a function call here, and we can pass s as a parameter to that function. We can do some arithmetic operation here, and we can use this s inside that arithmetic expression. So if you want to, or we can do some validation. We can assign some validation. So here is the question. The question is, if I assign status to some text value, then in that case, which it will print? Some text value. So I'm not clear, Chandrakant. Can you repeat the question? You can unmute and ask the question.
Suppose the status instead of integer 200, so can we assign to some other value also, right? Like suppose the status equal to some text value, some string value.
Oh, you are saying val. Let's see that val status is equal to Scala something, right?
Right.
So now it will fail here. Val status is equal to Scala. So it will say that found integer required was a string. Required was a string. So here we are using the literal value, actual value we are using. If I had specified only s, it would have worked. Since I'm using these things also actual values, it did not work. So what I'm meaning here is status match. So I can say so this works. This works. But if you are specifying the actual values, when you are specifying actual values, the data type has to be same. The data types has to be same. You cannot have a different data type. So, but again, we will come and understand when you start using these things in the Spark or otherwhere. We'll come to know as and as you get to work on this, you will get to know where to use such a thing, where not to use such a thing. There is one use case also I will try to showcase once we learn these syntaxes. Then we will see the where it is being used. So I can so keeping this in mind, coming back to the example, as I said now, S is binded with the value that is being passed to the match expression. So what is the use of having binding? The use of having binding is we can validate that, we can pass it as a parameter to some function, or we can use it as a expression in some arithmetic operation. Anything we can do it. Anything we can do it. Along with that, Scala also provides a built-in validation. Scala also provides a built-in validation with value binding. So it is called as pattern guard. It guards the pattern. It guards the pattern. There is some validation. We can check that what is the value of that binding. Whatever value binding we do, then we can check it. So pattern guard is simply an if condition. It's simply a if condition. So this is not the if expression. If expression is totally different. We have if and else which returns a value. So this is the name they have given it as a pattern guard. It is only a if. It is only a if here. So the way it looks like is, let's write here. So the same thing, I will change the status once again. I will make the status val status is equal to 404. Then I can say val message is equal to, I will first write the expression, then the match keyword, then I can say case, then I can say case 200 success, case 500, I will say critical error. Case yes, we said that value binding is happening. Along with value binding, I said that we can also have a pattern guard for just for some validation. So it comes immediately after the value binding, and it is one expression. Value binding and pattern guard together is one expression. Hence we don't require a semicolon here. We don't require a semicolon. It is one expression. So if I can have yes is equal to 404. So I can have such a validation here. Then I can say it is not found error. So I can use in this fashion. So that's the idea of having a value binding. That's the idea of having a value binding. So this time what happened? The value was binded to S. Now S is 404. Then we check here whether S is equal to 404. We can return. If it matches, the whole thing has to match. The whole thing has to match. Only if it matches, whatever is on the right hand side of this, it will be evaluated and it will be returned from the match expression, which is nothing but our. Yeah, that's the Rajshekhar. Yeah, that's what I was trying to say. This is not the if-else condition. This is not a if-else expression. It is just a pattern guard which only takes a if. Which only takes a if. But here we can write anything. On the right hand side of that symbol, on the right hand side of this, we can write anything. We can write a function. We can write a block of expression. We can write an if-else expression. Anything we can write. But here we cannot. Here it does not allow. It is a simple pattern guard. So I hope that was clear. Right. Now let's make here is a question from Chandrakant. Let's make status is equal to, instead of 100, I will make 302. Nothing like that. 100 also we can give, but I don't know what statement I have to, what string I have to return. I don't know what is a 100 return value, what it signifies. We know what is 302. 302 we can say it as a temporarily moved. So we can specify 100 also. No, nothing like that. No hard and fast rule. So let's run this program once again. Now status is 302. We have 200 success. We have 500 critical error. Then we have this. So this will not match. We know that clearly. This will also not match. We know that clearly. Now status value will be binded to S. S is 302. Then we check whether it is 404. Obviously this does not match again. So we know that none of the case matches. If none of the case matches, obviously we'll get a obviously we'll get a error. So in such a case, what do we do? In such a case, what do we do? So this is where the other one more wildcard pattern comes, which is a default, which is our default case. So we usually represent our default case with a underscore. So as I said, Scala extensively makes use of underscore. Based on where it is being used, the meaning of underscore will differ. So I can say here case underscore, which is our default, then I can say here so underscore is meaning default. If you see, we also saw underscore in tuple. We saw the tuple data type. There we use underscore 1, underscore 2, underscore 3 in that manner. To access the elements of the tuple, we used underscore. To have a default case in a match expression, we are using underscore. So that's what I was trying to say. Based on where it is being used, the meaning of underscore differs. There are some more other meanings also for the underscore, and we will be learning one by one. But I hope the match expression was clear. This is how we usually write a match expression. First, all the numeric types if you want, or the value binding we can use, and last will come as the default. If you put this default case at the start, none of the other cases, the compiler will never reach or evaluate that at all. None of the code will be reachable, because every time underscore will be reached. So you have to always keep it in that order. You have to always keep it in the order. So that's how the match expression works. So this is the simplest form of match expression, because we are working on primitive data type. Data types are either integer or it could be anything, but we haven't seen the complex data type. We will learn those things as well. But I hope till here things were clear. So we can also have in this fashion, and or we can have. So you can evaluate these examples. Day is we have set as Monday. The day will be evaluated. Monday string will be passed to the match block. It will check whether it is Monday or Tuesday. Anything here. If anything matches, whatever is on the right hand side of that symbol will be written here as a weekday. Otherwise, we are seeing it as a weekend. So in this fashion also we can use. Wildcard we saw, wildcard patterns, which is value binding. Any identifier you can specify. The value gets binded to that identifier. Similarly, underscore we know that is a default case. We can have a underscore. So all these things we have seen. Pattern guard we can have, conditions we can have conditions. So here, one use case of a match expression here is to determine the data type and do the uh, evaluation. What I mean to say here is, let's say I pass x here. I pass x to the match expression. Usually we can check if x is integer, do x plus y. If x is string, do x dot substring. I mean to say what y y dot substring method and call this function. If x is double, do some operation. If x is something else, do some operation. So what I'm trying to say here is you want to dynamically determine what is the data type of a identifier, and based on that data type you want to evaluate some expression. If it is an integer, do something. If it is a string, do something else. If it is a double, do something else. So you want to determine the data type dynamically, and based on that data type you want to do some functionality. So you can achieve that things using the match expression. Usually in Java, how do we do? In Java, how do we do? We check whether x is instance of. We check whether is instance of integer. If is instance of integer, do something. If is instance of string, do something else. If is an instance of some other object, do something else. So based on the data type of an object, we do something. So that can be achieved with the match expression here. So this is what we are trying to see. But before that, there are some things we forgot to say here. I forgot to say something here called as a, let's see that first. Otherwise this will become a bit confusing. So there is something called as a string interpolation. There is something called as a string interpolation in Scala, which is usually same as string formatting. Usually same as string formatting. What do I mean by string formatting? So if you see anything like, if I say val amount is equal to 200, so we can use something like this, right? The value of fruit is percentage %d, we specify string formatting in this format. In Java usually we say this dot format and we specify amount. So this is what we call string formatting. The similar string formatting we achieve in Scala, we do achieve, but it's a slightly different way, and it is called string interpolation. So let's see how it looks like. So val amount, I will say 200 here, 200 here. Usually how do I do in Java language? The value of fruit is percentage %d, dot format method is there on the string, and I specify amount. The value of fruit is this. But in here also it works. Along with that, they have some other fashion that is called string interpolation. We use a s as a prefix before the string. We just use a s as a prefix before the string. Then we say the value of fruit is, we don't use percentage %d here. We just specify the amount within the dollar symbol. So this will give me the same result. So this we call as a string interpolation, which is used for string formatting. Not only that, we can evaluate an expression also. A block of expression we can specify. I can specify a block of expression. I can say amount star 2. So that this gets, whatever is inside this block gets evaluated. And that evaluation happens only if there is a dollar symbol. So such things we can do. So we are formatting our string. So this we call as a string interpolation. In a similar fashion, if I want, let's say my amount is 10 point something, 10 point something, but I only want the first two decimal points. First two decimal points. Let's see whether it works with the string interpolation. Usually say the way we say is percentage dot. If I forgot that. I hope we say in this fashion. Here is a question: can I change the amount to double data type? In string interpolation, double data type. Can I change? The question is, can I change the amount to double data type in string interpolation? No, I don't think so. We can change it. Let's check. Let's check. I will come to that. Let's try that example. First, we will finish this example. As I said, I want only the first two decimal point. I want first two decimal point. That is, it has to give me 3, 4. But it did not work with the S prefix. It did not work with the S prefix. To make it work, we have to use a F prefix. We need to use a F prefix. So if you see, F prefix takes care of such things. Any decimal formatting you want to do, any decimal formatting, anything, any different kind of formatting you want to do, we use a F. Anything simple we want to do, we use a S. We use a S. We use a S. So that's the difference between S and F. These are the only two available. We can use S or F. So let's check with that question whether we can change the data type to double. The question was whether we can change the data type to double here. Amount is there. We know that amount is an integer. To double should work. I think so. No, it doesn't. It tries to work here. So 10 has been given as a double. It has been given as a double. Or we can also have such a thing, right? Amount is an integer. I can say into 3.4. I can say into 3.4. Obviously that will return as a double. 10 into 3.4 is a double. So you can evaluate anything inside that dollar. We can evaluate anything. So this is what we call as a string interpolation. This is what we call as a string interpolation. So coming back to the match expression, where I said I want to dynamically determine the data type and then evaluate based on the data type. So this is what that dynamic data type is. So if I see here, val x is equal to some integer. I said val x is equal to x. We know that is an integer because compiler automatically determined it as an integer. Then we are saying val y is of type any, which is the superclass of any class, which we don't know what is the data type. We can, any is a superclass, right? Any subclass object can be assigned to this. We know that. That's the generic rule. Any subclass object can be assigned to a superclass. A double could have also been assigned. A string could have also been assigned, or anything could have been assigned. So now why actual data type we don't know, or programmatically speaking, what is the data type of y we don't know. We know only that it is a X is integer, we know that, or compiler knows that. Now compiler doesn't know what is the data type of Y, actual data type. What is the value stored in the Y? Now how do I understand now? If it is an X, if it is an integer, I have to do something. If it is a string, I have to do something else. If it is double, I have to do something else. So that's where we can use pattern matching. Match expression we can use. I will pass Y to the match block. I will pass Y to the match block. So we know that Y gets evaluated. Y gets evaluated. After evaluating whatever value we get, that value will be passed to the match block. That value will be passed to the match block. So when we pass that value, this is how we do this. I can say case A, and I will check whether it is of the type string. That condition also is put here. We know that this is not kind of a condition. This is how we define a identifier. We are explicitly specifying it has to be a integer string identifier. If it is a string, if this matches, whatever is on the right hand side, it will be evaluated. On the right hand side, we are having a string interpolation, which will just return a character. If it is a double, we are just doing some more interpolation. We are only returning the decimal, 2 decimal point double. If it is a float, again we are returning only 2 decimal. If it is a long, we are just appending L here to the string interpolation. L is being appended. If it is an integer, I am just appending I here. So not more any complex things I am doing. We are just trying to differentiate what is the which data type it is, and based on that we are evaluating something. Based on that we are evaluating something. So I will just copy this and I will just paste it here. So obviously we know that X is an integer. Obviously we know that X is an integer. X did not match here because it was not a string, nor it did match here, nor it match here, nor it did match here. X was binded to A, but it is a string. X was binded to A, but it was a double. Nothing happened. This pattern matched. We know that value of Y when evaluated we get 12180, which is an integer that gets evaluated, or that pattern matches, and whatever is on the right hand side, which is nothing but our string interpolation. It is nothing but a string interpolation. And just concatenating I there. We evaluate A and concatenate I. So this is one of the use case of a match expression. But we will be looking more and more use cases of the match expression with the complex data type also. We'll be also checking with the complex data type. But I hope till here match expression was clear. I hope match expression was. Yeah, here is a question. Yeah, here is a question. After this symbol, can we put different data type? No, the idea here is we can put those things, but the idea here is we can write anything here. I can call a function also. I can create an object here. A class object can be created and a method can be called from here. I mean to say you can write your own business logics here based on what is the data type. So I hope, was that the question or you had something in its mind? I mean to say you can write anything here. Your business logic we can say.
So I think depends on that business logic. The
Correct.
return type is any type, right?
Right, right. B- biz,
So,
right, right.
so
That's true. If you have a totally different data type, here if we have a different data type, here if we have a different data type, then again I said that match is an expression. It will return a value. If you are returning different data types for different cases, a common parent data type will be returned and it will be assigned to message. So we have to make sure that we usually return the same data type based on the use case.
in this case, if I write a different data type, the output is any or kind of what type of data type is returning.
Yeah, it will be the common parent data type. Common parent. So meaning is the same. I mean to say, so if we are returning somewhere as, if we are returning in the match expression, if we return long somewhere, if we return character somewhere, in one case you return unit. So in that case, the common parent of everything is any value. So it will, the return data type will be this. So it depends on what you are returning. It's always the common parent. Always the common parent. So that's the match expression. We'll be using more and more. In Spark also we'll be using, just get used to these syntaxes, just get used to the concepts. And when we learn Spark, we will be using, going forward also we'll be using. I would recommend to keep on practicing these things. Write and practice. Next we have the loops. Next we have the loops here. So as I said, as we saw the if expression, as we saw the if expression, what does the if expression does? I mean to say, in other programming language. In other programming language, we modify. But in Scala what we do? We can modify also, that those things works as it is. But we also can, also we return something from here. The same thing holds good for also. In most of the other programming language, what we do is we modify something. We modify something. We usually modify, we compute the total. We usually do something, right? We will say where sum is equal to 0. Then we go through the loop for I is equal to 0, I less than 10, something, then I plus plus, then we say sum plus equal to 0. Sorry, sum plus equal to I. So usually we do this. We modify, we achieve mutability. We achieve mutability with the for expression. In Scala, we can do these things also, and we can return something from here also. Both, that's what I was trying to say here. Mostly I will be talking about mutability and immutability. So for is also an expression through which we can achieve mutability, through which we can achieve immutability also. So we'll see what are the use cases of mutability. We already know what are the use cases of mutability. To modify something in a loop, to compute aggregations, to a sum, or to modify a collection, anything. We'll also see what will be the use case of a for expression when we return some value from the for expression. When we return some value from the for. The syntax is a bit different here. Syntax is a bit different. Let's see what is the syntax. So the way we say is for I will say So this is a new symbol that we have got in for. New symbol. As I said, Scala extensively makes use of lot of symbols. So initially it may look tricky, but don't get back. I mean to say, don't lose anything. Just go ahead. Finally, it will be very fruitful. Then I can say instead of 1 to 7 something like this. So this is I run a normal integer for loop. This is how I run a normal integer for loop. And inside that I can just say so this is how we write a print statement, as simple as it looks like. So 1 to 7, just we have to say 1 to 7. So you'll get the things here. Day 1, day 2, day 3, day 7. This is how we. So I is equal to 0, I is less than 7, I plus plus. That doesn't work in Scala. That doesn't work. We have to use this syntax. So here 1 to 7, it will create a collection. So the generic idea here is, here it should be an identifier. Left side of the left side of the arrow should be an identifier. Right side of the arrow should be an iterator. So iterator is nothing but a superclass of a collection. And 1 to 7 gives you a collection from 1 to 7. And I will be looping from 1 to 7. I will be looping from 1 to 7. If I don't want 7, I want to exclude 7. In that case, I use until. I use until. So I can use the up arrow mark and get this. Oh, my mistake, not two L's, there is only one L, it will give a error. 1 until 7, 7 will be excluded. So we can see that 1 to 7. So this is how the for loop works. This is the simplest case of the for loop. And let's check what is the return value from the for. As I said, for is an expression. For is an expression, meaning it also has the capability to return some value. The compiler is designed such a way that it can return some value. So let's check what is the return value of for. Val x equal to for I 1 to 10. I will say println this. Let's see what is the return value. So if you see here, for expression returns unit. For expression returns unit. Meaning as of now we are using for expression as a mutability expression. As a statement we can say we are using it as a mutability. And what mutability we are achieving? We are writing to the console, we are modifying the console. We are writing to the console using the print statement. Using the print statement. So I hope this was clear. This is a simple syntax. This will by default increment by 1. Now let's say I don't want to increment by 1. I want to increment by 2. How do I do that? So if I want to increment by 2, I just say by 2 here. Initially day 1 we get, then 3, then 5, then 7, then 9. That's how we, if I want any delta value, you can specify any delta value. it should work fine. In a similar fashion, if I want to decrement, how do I do that? I don't want to go from 1 to 10. I want to go from 10 to 1. I want to go from 10 to 1. So in that case, I say by -1. In that case, I say by -1. Loop from 1 to 10 by minus. So this is how the for expression works. But we haven't, this is only the mutability of for expression we are seeing. We haven't seen the immutability functionality of the for expression. We will see that. What we'll do is we will wind up the session here because I have to leave a bit early today. We'll wind up the session here and we'll continue tomorrow.
Yeah, thanks, Pramod.
Yeah. Yeah, thank you everybody. I don't know, I don't have some of the people's email ID. Sudhakar email ID I don't have. And yeah, Kishore, I will share Kishore. Kishore, I did not share the video. I will share. Karunakar, I got it. Chandrakant, Divya, Jairam, Karunakar, Kishore. Yeah, Sudhakar, I don't have your email ID so that I can share the. I will share the videos.
Pramod, I have a quick question.
So yeah, go ahead.
Yeah, on the VirtualBox, do we have the IntelliJ already installed
Yes,
for Scala?
it is already installed.
Okay, okay, thanks.